In this video, we're going to get some practice with FFMP. So let's go ahead and under our Scales menu, select WFO for our scales. In the frames count, we'll start off at 12 frames. And then under the Scan menu, for the System for Convection Analysis and Nowcasting, we're looking for the FFMP section for flash flood monitoring and prediction. So the first thing we realize about the FFMP menus is we have all these different sources. We have individual radars listed here, and for every individual radar we have two precip sources. We have a DHR precip source, which comes from the digital hybrid reflectivity, which is effectively a cleaned up low altitude reflectivity that's used with a single ZR relationship to develop an instantaneous precip rate and then accumulate that. The other source from a single radar is going to be the digital precipitation rate source, which is a dual pole precip source, and the dual pole single radar algorithm uses a precipitation identification type to determine a spatially varying ZR, and then gives you an accumulation based off dual pole data. So in addition to the individual radar sources, we have mosaic sources. We have the HPE, or High Resolution Precipitation Estimator, which is a dual pole mosaic of all your nearby radars, all the DPR sources, and it combines those into one source. So it's easier to look at multiple radar information with just one source in FFMP. Even though this is labeled incorrectly DHR mosaic, it's a DPR mosaic, so by default it's a dual pole mosaic source. There's the bias HPE version, which the RFCs provide some gauge bias factors for individual radar sources, and those get sent over and can be used to correct some of the precip estimates with gauge observations. We also have the multi-radar and multi-sensor precipitation mosaic that's using a reflectivity-based mosaic, not dual pole data, but it has some spatially varying ZRs with its precipitation types that it assesses. So we have all these different precip sources. We don't have any of the mosaics in this case, so we're just going to use the single site radar for this exercise, which is fine because FFMP behaves the same for all sources. It's just a different data input. One of the things that you need to be able to do with FFMP is be able to look at some of the horizontal plots of some of the input data, like the flash flood guidance. So each source has this pull-out menu for guidance, and the River Forecast Center flash flood guidance is here. So you can look at the RFCs issue 1 hour flash flood guidance, 3 hour, and 6 hour flash flood guidance. So let's go ahead and select the 3 hour flash flood guidance. So what FFMP does with all its precip and all its flash flood guidance and all its sources is it takes this, in this case, a 1 kilometer by 1 kilometer gridded FFG. It's going to average that out over the small stream basins, and then it's going to give you the average value. So if I sample a point out here, this point says for a 3 hour duration flash flood guidance, I need about 2 1/4 inches of precipitation before I get to that, roughly the threshold where flash flooding threat becomes more significant. If I go up to the northwestern part of Oklahoma, we see that for a 3 hour duration, it's going to require over 6 inches of rain in a 3 hour period to trigger flash flooding up there. So you can start to see the kind of the variation of the inputs as it relates to the basin average flash flood guidance used in the FFMP displays. So let's go ahead and clear the display, and we'll go back to our sources menu for KTLX. And the other thing I'd like to point out, we don't have these in this data set, but I'll just point it out while we're here. Here's the average recurrence interval guidance source for, these are listed in years. So this is the 1 year average recurrence interval, the 100 year average recurrence interval, and then you've got all the different durations. So if I had the data, we could be showing a 3 hour duration for a 3 hour duration accumulation. What kind of event will I have in once in 100 year kind of event? Something that has a 1% chance of happening in any given year, and it may be 7 inches for a 3 hour accumulation, whereas we had the flash flood guidance said it was going to be up to 5. So the ARIs are really just it's like a precipitation climatology, just to give you some perspective on how rare is a given amount of precip and what's kind of the recurrence intervals for different precipitation amounts. And then it doesn't tell you anything explicitly about flash flooding, but the more rare the precip accumulation, probably the more likely flash flood threat is. But it's just one of the things to point out here. We also have QPF, which is quantitative precipitation forecast, and that's really difficult to do, and a lot of those are not very accurate, so we're not going to go over that here, but I'll just point it out while we're here. But let's go ahead and load KTLX DHR basin table. So one of the first things we recognize when we get the table up is that the frame count goes from 12 to 1. So FFMP defaults this by default so that it takes up less resources, because you can see this FFMP is a loading message, stays for a little bit when it first loads up. It has a lot of overhead to it, but it's not too bad once it's up and running. The other thing that we're going to notice here is that your display could come up differently than mine based off of what previous settings you had in there. So I'm going to want you to go under the D2D menu here, and we're going to select QPE. Then under layer, we can go ahead and select county to see. A lot of times it comes up in this county level display, which is the worst case basin. If there's any one basin that has the highest value, it's going to plot the whole county as a certain color. That's kind of one of the default displays, but that's not very useful for seeing exactly where the threat is. So we're going to go to all and only small basins. This is going to show us exactly where those basin average precipitation estimates are. And we can use our slider bar here to look at a 1 hour accumulation. Now, another thing to point out, this is a tip for using FFMP and some of the other decision assistance windows, which don't really dock in Cave. They sit outside of it. If I click on D2D, I keep losing my FFMP table. So I'm going to go ahead and right-click on the top of the window and select Always on Top, so I can interact with the display without having it hide in the table. Alright, so now I've got a 1 hour duration, D2D is QPE, and the layer is all and only small stream basin. So here's a label, 1 hour precipitation accumulation, and I see West Beaver Creek over here. If I left click on it, it's going to zoom in and put an X on that location. I can sample that out. 2.68 inches is 2.68 inches is what's listed in the QPE column. There's also an instantaneous precip rate, which this is that you take the DHR, you average it out over the basin to give you a reflectivity value, and then you convert to a precipitation rate using a ZR relationship. That's valid for an instantaneous precipitation rate. And that's in inches per hour. So it's raining right now because it's greater than 0, but an inch per hour is decent rainfall rate for an instantaneous rate, but that just tells you kind of instantaneously what's going on. Alright, so we covered those two. Now we can zoom out in our display and just look at, okay, where's the 1 hour precip accumulating the most, and we can sample these values. There's 3 inches down there. We can left click on the QPE in the table, and that's going to rank by QPE, and then we can left click on this 3.01 inch observation for that basin, and there she blows. So we can look at, I'm going to scroll out here, we can look at a 1 hour accumulation, we can look at a 3 hour accumulation, we can look at 4.5. So you can do anything you want with these precip accumulations in FFMP, and it's going to give you an updated estimate of the precipitation for that duration. And this is particularly important for things like the MRMS mosaics, the HPE mosaics. The HPE is only available as an hourly product. So you can't do a 3 hour accumulation of HPE anywhere else but FFMP. For MRMS, they just have the 2-minute data is just the hourly, the 1 hour accumulations, and the 3 hours, and the others are at the top of the hour. So if you want to find a 3 hour accumulation at 20 minutes after the hour at 21:25, let's say, you can't do that. So FFMP, one of its strengths is just as much for a precip source kind of slicer and dicer, just as much as it is to compare to flash flood guidance. So you can see things in FFMP for precip accumulation durations that you can't very easily in some of the other mosaics. So you can look at all different durations here for QPE, and then you could see basically where is the precip accumulated. So let's go ahead and select ratio under the table. and in the D2D display it's now going to be set to be ratio. So let's go ahead and left click on the ratio column just to see what is the maximum ratio for anywhere in our display. And if we left click on this top basin name, it's going to zoom into that particular basin. We can sample that value out and we see it's 151%. So let's go ahead and read off these values now for a given row. We're an all and only small stream basin, so this is all one basin's characteristics. The instantaneous precip rate of 1.79 inches per hour, which means it's raining right now. 3.64 inches has fallen in the last 3 hours because that's what I set my slider bar to be. The basin average flash flood guidance is 2.4 inches for this basin, so we can see that I've exceeded flash flood guidance. Well, if I take the ratio of QPE to guidance, then that's going to be 151%. And that's what we're displaying right here. So the neat thing about this ratio display is that the color table really pops at 100%. So whenever your QPE meets your flash flood guidance for that duration that you specify, anywhere that's purple is going to be exceeding flash flood guidance and has a flash flood threat if you believe your precip source and if you believe your guidance. And there's a lot of uncertainties with both, so it's not just a warn on purple here, but it's just something to clue you in as a place to look more carefully. So again, you can move these to any duration you want and see lots of different signals for isolated storms that are rate driven versus you do longer intervals, and you can see training storms, and so you'll see different signals on different durations depending on how much training you're getting in your precip accumulations. So that's ratio. Now we can also look at the difference product. So let's go ahead and under our D2D display select diff. Now we've gone ahead and we've changed the difference color legend in here to be more useful, to have more granularity around 0, because we really want to know when it's a quarter inch, half an inch close to a flash flood guidance and over flash flood guidance, more so than the defaults were like 1 inch categories, which doesn't help us very much. So we've modified this in all our cases, so it might be a little bit different than what you're used to seeing. But let's go ahead and left click on the difference column and see what's the maximum difference is 1.24 inches for this 3-hour duration. If we left click on that basin name, we can zoom in here and sample this value out to verify that yes, there's the difference of 1.24 inches over flash flood guidance, which is a significant amount. And if we look up here in the upper left, we see it's precip minus guidance difference for 3 hours. So it's 3.64 minus 2.4 inches is the flash flood guidance, and so the difference is 1.24. So anything positive, we're over flash flood guidance. The more over flash flood guidance we are in terms of the actual absolute value of precipitation accumulation, the more intense your flash flood threat is, or more significant your flash flooding threat is. So if you've got good precip estimates and good flash flood guidance, a half an inch over flash flood guidance is significant. An inch over flash flood guidance is usually very significant unless you've got errors in your flash flood guidance or your precip sources. So that's another thing we can do. We've looked at looking at QPE. We can have our D2D layer be ratio and just see where do I have flash flooding threat. We can look at a difference product for different durations and see where am I most exceeding flash flood guidance and by how much, and that gives us more of a sense of the threat for flash flooding the more you exceed flash flood guidance in a different sense. Okay, so there's a couple of things to point out here. We've been looking at basins right now which just have gray names on them, little gray boxes behind them. These are basin averaged quantities. But if you look down here, there's some of these basin names that are colored purple. So this is the El Reno Mesonet observation, and you'll notice that all the gauge observations are colored purple. These are called virtual gauge basins. So if we left click on this and we zoom in on this virtual gauge basin location, we'll see these little white squares in here are the locations of the gauges. So FFMP does two things. It does the aerial average for the regular basins. Then for the gauge locations, it makes these virtual gauges, virtual gauge basins, I should say. And it's valid at the point of the gauge, And what it does is it, instead of grabbing the nearby DHR and doing an aerial average over the basin, it's doing a point. It's grabbing the nearest DHR to that point. So it's really an apples to apples comparison between a point observation of the gauges and the point observation of the DHR, so that we accumulate that nearest grid point of the DHR to that gauge and use that as a precip source, and accumulate that. And then it has in the basin trends, there's a virtual gauge basin overlay display, which we'll show you in the next lesson. But this guy right here is going to be tied to your virtual gauge basin, and it's going to allow you to compare the precip to the actual what goes on inside the gauges. But that was a little look ahead using a right click on that basin name. But we'll get to that in the second lesson. I just wanted to point out that anything in purple isn't an aerial average, it's a virtual gauge basin. That's kind of a point observation of the accumulation of the DHR product. So we've gone over, you can rank all the tables by the different amounts. We've gone through the QPE, ratio, and difference. The other thing that we can do is look at the attributes button. And when we click on the attributes, let's go ahead and look at this. We're going to sort by QPE for 3 hours. Let's left click on that 3.64 inches here. And we're going to sample that out and see. Let's see, we're on diff here. Let's go ahead and change our D2D to QPE. All right, so we've got 3.64 inches has accumulated over the last 3 hours in this basin. And all the basin names, if they haven't been defined, are going to be shown up as XXXX, and they each have a unique integer ID. But we have a basin here that we're trying to figure out, well, how significant is this 3.64 inches in 3 hours? Do we get this all the time, or is this really rare? So this is where we can start to bring into the ARIs into the discussion. So if we click on the attributes button, we can bring this over, and we can go ahead and let's toggle on the 1 year recurrence interval to find out what has a 100% chance of happening in a given year. That's going to be a 1.93 inches is a 1 year recurrence interval precipitation. So we're well above that. So this isn't just your average kind of event. We can click on the 10 year recurrence interval and see what's that. That's 3.39 inches will happen once in every 10 years. So there's a 10% chance of it happening in any given year. So we're starting to get up into a somewhat rare precipitation accumulation. So let's go ahead and deselect the 10 and select 100, because this kind of adds up after a while with lots of columns in here. We see a 1% chance event for the maximum precip is going to be 5.78 inches. It's kind of a 100-year recurrence, 1% chance of happening in any given year. So we're not in super record territory right now with this, but it is an anomalous precipitation that's got a 10% chance of happening in any given year. And that just gives us another perspective on how rare is this precipitation accumulation for this duration. So that's a way you can control the columns that are displayed in the FFMP table, as well as add some of these ARI values in. So we've looked at the all and only small stream basins, and this gives us a direct look. We can go into D2D and go ratio, show me where I have a flash flood guidance threat. Anywhere that's purple, I'm over 100%. It gives me a sense for the immediate place to look for the flash flooding threat. But one of the things that we can also do, if we're trying to find a particular basin name in here, you'll see that these basins, there's just literally thousands of basins at times in some CWAs. So it can be hard to find a particular basin name. Even if you kind of sort this and you try and find something, it can take a long time. So the reason why we have, the main reason why we have a county level or county layer display, if we click on county, it's going to give us, I'm going to go ahead and sort again by QPE, left click on the QPE. And this gives us a worst case basin in here. So this is the highest instantaneous precip rate for any basin in Canadian County is 4.09 inches per hour. The highest QPE for this 1.75 hour duration is going to be 3.63 inches. lowest flash flood guidance in that county for any basin is 1.95, and then the highest ratio in diff is 171% and 1.5 inches. So these are not all the same basin. These are just the worst case basin for any one of these parameters. So not very helpful, but at least you can kind of get what you're looking at when you're looking at the county level displays. So let's say I want to find out a particular, what's going on in a particular basin in Canadian County because I know my counties. Well, what happens when you go in the county level display, the default setting for the zoom factor is only basins in parent, so it just keeps the basins in the parent that are just the basins that are in that county. So we've got a lot less basins to kind of sort through to find something find something particular that we want to evaluate. So now the flash flood threat many times crosses county boundaries, so it doesn't really help in that respect. But if you're trying to find a particular basin, this can be one way to isolate that with that setting. Now you can also turn off the only basins in parent, and then you'll see all the other basins around it. So there's more sophisticated bells and whistles with the FFMP basin table that you can use to filter some of these on and off, but we're going to try and keep it simple to start with. And if we want to return back from our county level display to the regular display, we just click the county button again for Canadian County and it will zoom back out. Okay, so we've introduced you to the scan menu, the FFMP sources. You can look at flash flood guidance displays through that are basin averaged. We can load up D2D. We can look at QPE for different different durations. We can also we like to recommend going to the all and only small stream basins perspective so that we can kind of see what's the most significant precip and where has it fallen, and look at it on its actual basin averaged area. We can look at things like ratio and difference, where these ratio and differences are using the RFC flash flood guidance as a QPE to flash flood guidance ratio and diff, and that's selected down here. The guidance source, you could technically have your ratio be a QPE to a recurrence interval for a 100-year recurrence interval if you wanted to use it as a guidance source, but there's no hard and fast numbers for what recurrence interval is equating to flash flooding at your office. So it's really more ambiguous to actually change those values. It's important to just leave the RFC FFG by default when you're getting used to this, so that your ratios and differences are going to be using the flash flood guidance like most people are used to using. Otherwise, you can use the attributes button, and you can add the ARIs in there, reconfigure some of the columns in here. And so I think this is a good introduction to the basics of the FFMP table, kind of the horizontal displays and how to identify areas of flash flooding threat through the D2D.